Dubrow Suspicion Files.
How can you be certain you are awake right now? No, I mean truly 100% certain that the world you perceive, the density of the air, the physical feel of the chair you're in, the voice you're listening to, isn't just elaborate, deeply textured software.
It is really the ultimate philosophical question, isn't it? But it's one that has been given this massive 21st century technological upgrade.
Yeah, completely.
I mean, think of the ancient texts. The philosopher Zhuangzi, he famously dreamed he was a butterfly.
Right, just fluttering around.
Totally free of his human form. And when he woke up, he was just plagued by this profound uncertainty. Was he a man who had dreamed he was a butterfly, or was he a butterfly now dreaming he was a man?
And that used to be the domain of poets, of mystics, of monks meditating on the slipperiness of existence.
Exactly.
But today, it's a question for engineers, physicists, and computer scientists. They're all debating the limits of, computation and complexity.
We've collectively moved the entire proposition from is reality an illusion to a far more aggressive, almost an engineering question.
Is reality a computation?
Precisely. And that is the central claim of what we call the simulation hypothesis. The idea that the entire universe, with all its fundamental laws of physics, its vast scale, and the startling complexity of our own consciousness,
Is nothing more than a program.
Yeah, a highly sophisticated computer program running on some device that is just far beyond our current comprehension.
Welcome to the deep dive. This topic, Case File 042, Are We Living in a Computation? It generates a colossal stack of sources.
So it's huge.
Some are rigorous, some are, wildly speculative, and a lot of them are conflicting. So our mission today is to act as your guides, to help you quickly but thoroughly synthesize all this material.
We're going to examine the evidence, like prosecutors and defense attorneys. We'll look at the logic, the physics.
And the really bizarre alleged glitches that proponents claim prove we're living in a digital world.
Our objective is not to tell you the answer. It's to give you the clearest path to those aha moments that clarify the whole debate, to help you distinguish rigorous thought from, pure speculation.
By the end of this deep dive, you will have all the necessary knowledge to render your own final judgment. Let's start at the absolute foundation. The argument that initially gave this idea its intellectual teeth.
Right.
We're not starting with physics or observed anomalies. We are starting with pure, unadulterated statistical logic.
Specifically, the work of philosopher Nick Bostrom in his 2003 paper, Are You Living in a Computer Simulation?
The famous one?
That's the one. And Bostrom's paper is brilliant, really, precisely because it doesn't try to prove anything about our current reality.
It's not about evidence.
Not at all. Instead, it relies entirely on a formal statistical construct. We call it Bostrom's Trilemma. It posits that, based on simple probabilities projected into the future, one of three mutually exclusive possibilities must be true.
Okay, let's unpack this logical requirement. The whole thing seems to hinge on whether a civilization can achieve what he calls a post-human technological stage.
Yes.
Define that for us.
So a post-human stage means reaching a level of technological mastery where a civilization has computational resources that are just so vast and their energy management is so efficient.
That they could actually do it. They could run an entire ancestor simulation.
Exactly. A simulation detailed enough to create conscious minds that believe themselves to be real, operating in a reality that's totally indistinguishable from their own history.
So, assuming that capacity is the dividing line, what are the three inescapable propositions in this trilemma?
Okay, so first up is Proposition 1. The human species, or any intelligent species like us, is very likely to go extinct before reaching that post-human stage.
Which seems plausible.
Very plausible. I mean, this can be due to self-inflicted catastrophes, right? Advanced warfare, bioengineered plagues, environmental collapse. The future simply runs out before the simulation technology ever arrives.
A sobering thought. Okay, what's the second logical escape hatch?
Proposition 2 is that post-human civilizations, even if they do reach that level of, godlike computational power,
They just choose not to.
they're extremely unlikely to run a significant number of ancestor simulations. And there could be a ton of reasons for this. Maybe they find it unethical to create billions of conscious, suffering minds.
Or they just get bored.
Or they get bored with history.
Yeah.
They'd rather simulate, fantasy worlds. Or maybe they just realize the immense computational cost just isn't worth the scientific return.
Okay, and the third option, which is the one that gets all the headlines, is the only one left if the first two turn out to be false.
Exactly. Proposition 3. We are almost certainly living in a computer simulation. And the argument here is purely statistical. It rests entirely on what happens if we negate 1.
So we survive and thrive.
And we negate 2.
They do decide to run the simulations.
Right.
Tell us how that statistical leap to almost certainty is made. It feels like a big jump.
It's just the sheer weight of numbers. If a post-human civilization achieves even, let's say, a modest technological supremacy, their computing power would let them run billions, maybe even trillions, of these ancestor simulations at the same time. And each one of these simulated universes would contain billions of conscious simulated minds.
And compared to that colossal simulated population,
The number of original biological minds in the one single base reality would be minuscule, a drop in the ocean.
so the math is simple.
The math is simple. If you are a randomly selected conscious mind, which you are, the statistical odds are overwhelmingly stacked against you being one of the rare biological originals.
You're almost certain to be one of the trillions of simulated ones.
Statistically, yes. The probability isn't based on physics. It's just based on the ratio of possible simulated minds to possible biological minds.
That statistical elegance, I have to admit, makes the argument feel pretty ironclad. But we need to act as the defense attorney here. Where are the logical vulnerabilities in this perfect trilemma?
They're deep-seated, actually. Because the argument, while it's mathematically sound, it doesn't address the most fundamental metaphysical problem. The first major logical trap is the problem of infinite regress.
Okay, so if we are simulated, then our simulators are subject to the same logical rules we are.
Precisely. If our simulators reach the post-human stage, the trilemma applies to them, too.
So the odds are they're probably simulated.
Exactly. And who simulated their simulators? You end up with this stack of realities layered one on top of the other, like Russian stacking dolls.
It just pushes the question up a level.
Forever. It never actually answers the origin problem. The hypothesis only displaces the mystery. It doesn't solve it.
That's a powerful challenge. I mean, a true theory of reality should logically terminate at the origin, not just generate an infinite chain of assumptions.
And the second critical vulnerability is that the hypothesis, well, it fundamentally violates Occam's razor.
Right. The principle that among competing hypotheses, the one that requires the fewest assumptions is generally the most likely to be correct.
Let's compare the two scenarios clearly.
Yeah.
Scenario A, the base leap reality. One physical reality exists. That's one assumption.
Simple enough.
Now, scenario B, the simulation hypothesis. One base reality exists, plus a massive post-human civilization, plus unimaginable near-limitless computational resources, plus a specific motive, which we can't possibly know, to run these simulations.
It's just adding layer after layer of complexity.
Exactly. The simulation hypothesis requires multiple layers of required unproven complexity. The biggest assumption being the existence of this higher-order civilization with the will and the means to run us. It is demonstrably not the simpler explanation.
So the very elegance of the statistical argument relies on these highly complex, completely unproven assumptions about a higher-order universe.
That's it. And that brings us to the greatest flaw. This entire construct is probabilistic, but it is built on zero empirical data.
Right.
We're applying the rules and technological scaling curves of our universe, our computational projections, our current interests in VR, and we're just applying them blindly to a hypothetical higher-order universe we know absolutely nothing about.
So it's pure speculation.
It's an extraordinary exercise in what we'd call O-tier 3 speculation, but it's masquerading as an ironclad logical certainty.
Okay, so the trilemma might be purely academic, but the simulation hypothesis, it really exploded into the global consciousness when tech leaders like Elon Musk adopted it.
It did.
This is where we transition from abstract logic to, observable exponential technological trends.
Musk stated this was the strongest argument he knew for the hypothesis. And it's compelling because it relies on our own experience witnessing the relentless pace of Moore's law and technological advancement over the last few decades.
The famous analogy he used captures the scale perfectly. He said, look at the history of simulated reality. 40 years ago, simulated reality was Pong.
Yeah. Two simple rectangles and a dot.
That was it.
And now we have photorealistic, fully immersive 3D simulations, games like Grand Theft Auto or advanced VR environments that millions of people can inhabit simultaneously.
The progression isn't linear at all, it's exponential.
Exactly. Musk concluded that if this rate of improvement continues, these simulations will soon be indistinguishable from reality.
Which means the odds of being in the one base reality are quickly diminishing to 1 in billions.
Right.
That feels entirely plausible because we see that technological curve continuing upwards every single day. But this enthusiasm was enough to convince even, hardened astrophysicists, right?
It was. Neil deGrasse Tyson, among others, he admitted he was initially convinced. He called it
Right.
very likely we were simulated.
But he's changed his mind.
He has. Upon closer analysis, many scientists, including Tyson, have reversed or at least significantly moderated their positions. The defense found some pretty serious flaws in just projecting our current tech trajectory onto infinite possibility.
Okay, so what were the counter-arguments to this kind of technological optimism?
Well, the first objection is what we might call the problem of motive in sociology. And this takes us completely out of the realm of physics and into pure speculation about consciousness.
The why question.
The why question. If a simulator has godlike computational power, capable of designing and running an entire cosmos, why on earth would they choose to simulate this?
Our current time period, with all its inherent flaws, inefficiencies, and just general messiness.
Exactly. Tyson argued that our current timeline, plagued by political conflict, social inequality, existential threats, is statistically just uninteresting as a project.
If they can simulate anything.
Right. Why not simulate a post-scarcity utopia? Or a wildly fantastical reality with different laws of physics? Or maybe just their own far future? If we are a simulation, we're likely a tiny, pretty uninteresting historical sandbox.
This is a critical pivot, then. We are no longer debating the computational speed of their hypothetical processors. We are debating the potential motivations, the ethical frameworks, the boredom levels of a hypothetical post-human civilization.
It's speculation about their society, not evidence about ours. And that sociological uncertainty severely weakens the idea of almost certainty. If we don't know why they would run us, we can't just assume they will run billions of us.
Okay, but the more serious objection, the one based on hard physics, has to be the question of computational resources.
Right.
The Musk argument kind of assumes that technology will just overcome all physical constraints. Does physics agree with that?
Absolutely not. Not even close. While our classical computing improves exponentially, the universe isn't based on classical mechanics. It's based on quantum mechanics.
And that's a whole different level of complexity.
The physical reality is infinitely more complex than even the most detailed open-world video game map.
So how does that quantum complexity translate into this, exponentially prohibitive cost?
This is where we can actually look at specific calculations. Physicists Zohar Ringel and Dmitry Kovrizhin did this in 2017. They investigated the cost of simulating reality down to the quantum level.
And what did they find?
The problem is that quantum systems involve entanglement and superposition. So the complexity isn't just about storing classical data points. It's about modeling the vast dynamic interactions of all potential states.
So as the number of simulated quantum particles increases, the computational cost doesn't go up linearly.
It goes up exponentially. Precisely. If you have n quantum particles, the number of classical bits of information you need to simulate them accurately is 2 to the power of n.
Oh, wow.
This growth is so rapid, so extreme, that Ringel and Kovrizhin calculated that simulating even just one relatively small quantum system would require resources that quickly surpass all the available energy and hardware in the entire known universe.
That is an absolute physical ceiling. We're talking about energy that literally doesn't exist in our universe to simulate even a fraction of it.
Exactly. Even achieving post-human technology doesn't mean you can break the fundamental laws of energy conservation. The universe, in its current formulation, is simply too computationally complex to be simulated efficiently by a classical computer, even one with nearly limitless power.
So the complexity of reality is exponential.
And our projected technological advancements are not sufficient to meet that exponential computational demand. The universe is far, far more complex than just a high-resolution version of Planck.
Okay, so we've tackled the macro-level arguments, the logic of probability, and the physics of computation. Now let's turn to the evidence that feels the most personal to us, to the listener.
The glitches.
The glitches. If the universe is too complex for a computer, why do our own brains still offer up this feeling that things are breaking? Proponents claim these common, profound experiences are glitches in the matrix.
Right. And to understand this, we need to move the discussion inside the skull and examine the supposed failures in reality that are in fact stunning successes of our own biology.
So we're looking at the Mandela effect and déjà vu.
Those are the big two.
Let's start with the Mandela effect. This is the phenomenon where millions of people share a specific, often very detailed, collective false memory. The name itself comes from the large group of people who vividly recall Nelson Mandela dying in prison back in the 1980s.
Which, of course, didn't happen.
Right. But the most definitive example, the one often cited by simulation proponents as hard evidence of some kind of data error, is the famous spelling of the children's book series.
Ah, yes.
Millions of people, myself included, swear they grew up reading The Berenstain Bears with an E.
But the confirmed ACE Tier 1 hard evidence of reality is that it has always been spelled Berenstain.
Which feels wrong even saying it.
It does, and so the simulation claim is irresistible. This must be a program patch or a system reboot.
Yeah.
And our individual minds, the outdated software, are retaining these corrupted memory files from the version before the patch.
It's a compelling narrative, I'll give him that.
It is, but the scientific case file on this is definitive. This is not an external reality failing. It's our internal neurology functioning precisely as documented. We're not experiencing a system crash. We're experiencing the mechanics of human memory.
Okay, so what is the specific neurological mechanism that causes millions of people to swear they remember something that just never happened?
There are two precise concepts at play here. The first is confabulation. You have to understand that your brain is not a reliable video recorder.
Right, it doesn't just store files.
No. It does not archive experiences as static files. When you recall a memory, your brain actively rebuilds it. It fills in the gaps in the narrative to make it coherent and logical. Confabulation is the brain's attempt to guess the most likely, most coherent version of an event.
So in the Berenstain example, my brain sees the suffix stain, recognizes it's pretty uncommon, compares it to the far more common German-derived suffix stein, and then just reconstructs the memory using the common pattern.
It's essentially autocorrect for the mind.
That's a great way to put it.
Or think about common movie quotes. Almost everyone remembers the line, "Luke, I am your father." But the actual line is, "No, I am your father." Your brain applies coherence to make the memory simpler and more likely, and that error gets baked in during the reconstructive process. You aren't lying. Your brain is guessing.
And the power of the internet just reinforces these collective guesses, creating a false consensus.
Which is the second factor, social reinforcement. The moment someone posts a reconstructed error online, thousands of others who independently made the same confabulation immediately agree. Me too!
Yeah.
That shared conviction transforms a simple neurological error into a cultural certainty. It's evidence of highly similar human brains, not a shared operating system crash.
Okay, let's move to the second major glitch, déjà vu. That sudden, arresting, almost chilling feeling that you have lived this exact moment before.
Down to the details.
Down to the exact placement of objects and the words being spoken. The simulation claim is pretty profound here.
Yeah, the hypothesis suggests that a minor program glitch occurred, maybe a failed rendering or something, and the developers decided to fix it by just rolling back the system.
Rewinding our individual consciousnesses a few seconds to cover their tracks.
And we feel the echo of the moment that was just erased.
Again, it's a brilliant narrative, but what does the scientific literature say about this really profound sensation?
It is not a developer rewind. It is a measurable brain processing delay. We can trace the scientific understanding back to foundational work, like the 1965 dual processing theory proposed by a scientist named Robert Efron.
Okay, so walk us through the mechanism of that delay. Where is the signal getting crossed?
So when you experience the world, sensory input enters your temporal lobe, which handles the processing of time and memory.
Got it.
The signal that registers the raw, immediate experience enters first. A fraction of a second later, a second signal enters. And this is the signal that represents the brain's conscious awareness and timestamping of that experience.
And when déjà vu occurs, what's happening then?
When the brain's systems are momentarily stressed, maybe due to fatigue or a momentary disruption in the hippocampus, the delay between those two incoming signals gets slightly prolonged.
By how much?
Maybe by milliseconds, sometimes even a full second. And that small lag causes your brain to misinterpret the second signal, the awareness signal, as a past event.
So you are quite literally remembering the present moment as it is unfolding.
Exactly. The time-stamping mechanism has been delayed just enough to categorize the experience as a memory.
That makes the phenomenon not mystical at all, but purely mechanical. It's a documented consequence of a known neurological function tied to the timing of signal transmission in the temporal lobe.
And we know this phenomenon is real because it's often documented as a non-fatal precursor to specific neurological events.
Like what?
Like temporal lobe epilepsy seizures.
Hmm.
The system is operating consistently, even when that consistency feels profoundly strange to the user. The glitches are not external code errors. They are internal hardware diagnostics.
Okay, so if the logical argument is based on projection and the glitches are based on neurology, the simulation hypothesis has to ultimately find its strongest proof in the fundamental laws of nature itself.
It has to.
This is Exhibit D, the claim that if you look closely enough at physics, you can actually see the fingerprints of the program's source code.
Right. And we need to examine 3 scientific claims the proponents cite as Tier 1, hard evidence, of a programmed reality, starting with the most compelling one, fine-tuning.
The argument being that the physical constants of our universe are perfectly balanced, balanced on a razor's edge and seemingly optimized for the formation of life. This suggests design.
The precision is truly breathtaking. You consider the fundamental constants, the strength of gravity, the charge of an electron, the relationship between electromagnetism and the weak nuclear force. For life to exist, these numbers have to fall into an astonishingly narrow range.
Give us the specific, dramatic example of this precision.
Okay, take the strong nuclear force. This is the force that binds protons and neutrons together in an atomic nucleus.
Right.
Physicist Paul Davies illustrated that if this force were even just 2% stronger than it currently is,
2%.
all hydrogen would immediately fuse into diprotons. The consequence: no stable hydrogen, no water, no long-lived stars to generate heavier elements, and thus no life. The universe would have been just a brief, sterile flash of energy.
That fine-tuning does suggest a highly specific designer or a tuner. It's a powerful piece of evidence.
It is.
So how does science, operating under the assumption of a natural, non-programmed universe, rebut this apparent design?
With an argument that is logically sound, but often psychologically unsatisfying. It's called the Anthropic Principle. And this isn't a physical law. It's a statement about observational necessity. It's a selection bias.
Let's revisit that analogy you mentioned earlier, the puddle of water.
Right. So imagine a puddle sitting in a depression in the earth. The puddle marvels, wow, this hole is perfectly shaped for my existence. My depth matches the deepest part. My lateral shape fits the boundaries exactly.
But the logical reality is,
the puddle exists only in a hole whose shape allows it to exist. If the shape were different, the puddle wouldn't be there to marvel at the fit.
and we are that puddle. We must observe a universe whose constants allow for observers, or we wouldn't be here to have this conversation.
Exactly. The fact that the universe is suitable for life is a prerequisite for our presence. This is the weaker form of the principle, the selection bias. The stronger philosophical counter is the idea of a multiverse, an infinite collection of universes where constants randomly vary.
And we just happen to be in the one that worked.
We must necessarily find ourselves in the one where the constants are right. The Anthropic Principle is the most parsimonious, the simplest explanation, but it doesn't satisfy our innate curiosity about why those numbers are what they are.
Okay, next claim. Any computation needs discrete units, or pixels, and the claim is that Planck pixelation provides the minimum resolution of our simulation.
The Planck length is indeed a real mathematical limit, the smallest possible unit of distance. And proponents argue that since reality can't be infinitely continuous in a simulation, this Planck length must be the pixel size or the boundary resolution of the universe's graphics engine.
This sounds incredibly convincing. Why is the Planck length not a pixel?
Because the interpretation is a common misconception about what the Planck length actually represents. It's a mathematical unit you get by combining the three fundamental constants of quantum mechanics, relativity, and gravity.
Okay.
It represents the scale at which our two most successful theories, general relativity, which governs the large, and quantum mechanics, which governs the small, they break down. They become mutually incompatible.
So it's the limit of our current knowledge and mathematical models, not necessarily the limit of physical reality itself.
Precisely. We can't model what happens below that scale yet. It's sort of a math trick to mark where our equations stop working. But more critically, the simplest, most intuitive models of a pixelated universe have been empirically falsified.
How is this actually tested in the real world?
Researchers used data from the Fermi Gamma Ray Space Telescope to look for evidence of this grid. If spacetime were run on a fixed grid, higher energy photons, which are essentially shorter wavelengths, would be slightly more susceptible to the jagged edges of those pixels.
Causing them to travel slightly slower.
Exactly. Like digital drag or latency over cosmic distances. So they observed high-energy photons emitted from distant gamma-ray bursts, billions of light years away.
And if the pixel models were correct?
The higher-energy photons should have arrived slightly delayed. The result, they arrived simultaneously. This lack of a pixel-based delay contradicts the simplest models of a fixed, chunky digital grid.
All right, let's move to the third, most advanced, and arguably the most startling piece of alleged evidence: the code. This relies on the work of theoretical physicist James Gates Jr.
Yes, Gates was working on highly advanced equations in supersymmetry theory, trying to unify quantum mechanics and general relativity. During his really complex work, he found these specific, non-trivial mathematical structures embedded deep within his equations.
And these structures, by his own description, were doubly even self-dual binary linear block codes.
Which, I mean, that sounds like a mouthful, but those are the exact specific type of literal error-correcting codes used by your computer when it transmits data across the internet.
The stuff that ensures my browser renders a page correctly or checks the integrity of a hard drive.
That's the stuff. So proponents claim this is the universe literally shouting, "I am written in code."
That sounds like a powerful smoking gun. How is this interpreted as anything other than intentional programming?
This is perhaps the most profound misrepresentation in the entire debate. What Gates discovered was that the same incredibly efficient, elegant, and structured mathematical language that humans use for error correction
Also happens to be the language that describes the equations of supersymmetry.
Yes, it's an argument from analogy, not identity. Think of it like this. We find the same mathematical structures, let's say prime numbers, used to design both the perfect structure of a DNA helix and the perfect structure of a super-efficient computer algorithm.
Does that mean DNA was programmed?
No. It means both DNA and the algorithm are constrained by the same universal rules of mathematics.
I see. And Gates himself used these visual tools, Dinker symbols, to help visualize the complex equations, which I'm sure just fueled the whole matrix code narrative.
It absolutely did. But these symbols were a visualization tool for the math, not the discovered code itself. His finding reveals a deep truth, that mathematics itself, the fundamental language of existence, is inherently beautiful, structured, and capable of self-correction and efficiency.
Which suggests an elegant base reality, not necessarily a programmed one.
Right. If the language of base reality is math, and math is universal, then efficient structures are just inevitable, regardless of who or what created them. So we've established that the arguments are either circular, neurological, or based on mathematical coincidence. And this brings us to a fundamental question. When does speculation stop and science actually begin?
That is the ultimate test, the Karl Popper criterion. For a hypothesis to be considered scientific, it has to be falsifiable. We have to be able to design an experiment that could, in principle, prove the hypothesis wrong. Can the simulation hypothesis pass the Popper test?
Researchers have certainly dedicated time to this. In 2012, a group of physicists, Silas Bean, Zohre Davudi, and Martin Savage, they proposed one of the most cited possible tests. They were trying to find a measurable artifact of the simulation hardware.
And what was their hypothesized smoking gun for the existence of a simulation's underlying structure?
They argued that any computer-running reality would have to simplify space and time into a grid, what they called a cubic space-time lattice.
Okay.
And if this fundamental 3D grid existed, it would leave a signature called rotational symmetry breaking.
That's a highly technical term. Let's translate rotational symmetry breaking for the listener.
Right. So in a natural, non-simulated universe, physics should look the same no matter which direction you look or turn. That's rotational symmetry.
It shouldn't have a preferred direction, like up should be the same as sideways, fundamentally.
Exactly. But if the universe is run on a fixed cubic grid like a digital coordinate system, that grid would impose a preferred set of directions.
The X, Y, and Z axes.
Right. And this directional preference would cause high-energy particles to interact differently when traveling along the grid axis versus traveling diagonally.
So they predicted that ultra-high-energy cosmic rays, which should arrive randomly and uniformly from all directions, would instead cluster in specific patterns that reflect the underlying simulation grid.
A detectable, measurable pattern that would expose the simulation's resolution. It sounds like a legitimate, performable scientific test designed to falsify the idea of a natural, smooth reality.
But what was the outcome?
The test remains, at present, unperformable.
Unperformable because the resources don't exist.
Unperformable because of the specific data required. The physicists need data on the highest energy cosmic rays, and those are incredibly rare. To get a statistically significant sample to observe this rotational symmetry breaking, they estimated we would need centuries of data collection.
How rare are we talking?
A single square kilometer on Earth is hit by one of these required rays only once per century.
So the universe is simply not cooperating with the timeline required for falsification. We can pose the test, but we can't perform it anytime soon.
Which leaves the hypothesis purely theoretical by logistical constraint. And that's why the debate quickly shifted back to more philosophical proposals. In 2022, a physicist named Melvin Vobson proposed the second law of infodynamics.
Okay.
He suggested that just as the second law of thermodynamics states that energy disorder entropy always increases, there's an equivalent law for information.
And what did Vobson claim about information entropy?
He claimed that, conversely, information entropy decreases. He suggested the universe is actively and constantly engaged in a computational optimization mechanism.
Like the physical world is constantly streamlining its information, like a massive hard drive running an optimization program.
That's the idea. And if that were true, it would strongly suggest computation.
Has the scientific community accepted this?
Absolutely not. This is a proposed hypothesis from a single researcher, and the immediate reaction from the broader scientific community has been to publish critiques, attempt to reformulate his concepts, and point out logical and physical inconsistencies.
So it's not a scientific discovery or an accepted law?
Not at all. It is the very beginning of a heated scientific debate. The jury is way out, and the evidence is shaky at best.
It's a fast-moving philosophical field, though. We even have sources pointing to a 2025 paper that mathematically claimed the universe is not a simulation, using a totally different framework.
Yeah, that paper bypassed the physical constraints entirely. They argued that any simulation has to be fundamentally algorithmic based on repeatable computational rules.
Okay.
However, they claimed the universe incorporates non-algorithmic understanding and Gödelian truths, which are concepts that demonstrate reality contains inherent complexity that no purely algorithmic computer could ever replicate or fully describe.
That's a deep philosophical counter. If reality contains true, non-computable truths, then it cannot, by definition, be a computation itself.
The conclusion is unavoidable. We have a statistical argument based on projection, physical arguments based on interpretation, and tests that are either centuries away or still under intense scientific scrutiny.
So the current status of the simulation hypothesis is?
It's definitively metaphysical, not scientific. It cannot be falsified with current technology.
Okay, we've reviewed the case file, and the evidence for the simulation hypothesis is profoundly weak.
To put it mildly.
The logic is circular, the glitches are neurology, the code is complex mathematics. So the essential question remains, if the evidence is so thin, why is this idea so incredibly compelling? Why do so many intelligent people, from high-profile figures to curious listeners, find it almost irresistible?
Because, as our sources suggest, the simulation hypothesis maps perfectly onto these deep, ancient cognitive biases that are hardwired into the human brain. We are predisposed to believe in this kind of structure.
Let's break down those psychological attractors, starting with patternicity.
Patternicity is just the inherent tendency to find meaningful patterns in meaningless noise. Our ancestors evolved in an environment where it was much safer to assume structure than randomness.
Right.
Evolution taught us to make a type I error. Seeing the rustle in the grass and assuming it's a predator, a false positive, is much better than assuming it's just the wind, a potentially fatal false negative.
So we are hardwired to prefer structure. And we apply the same survival mechanism to the entire cosmos. We look at the data, the fine-tuning, the constants, the mathematical structures, and our ancient brain says that pattern cannot be random chance. That must mean something.
Which leads directly to its companion bias, agenticity.
Yeah.
We don't just see a pattern. We infuse that pattern with conscious intent or agency.
We see the cosmic fine-tuning.
And we immediately invent the fine-tuner.
Yeah.
We see the code, and we invent the programmer. Agenticity is the psychological engine that turns correlation into causation and structure into design.
There's also the question of scale, which activates the proportionality bias.
Yes. This bias is the belief that big effects must have causes of a correspondingly massive scale.
And our universe, all of reality, is the biggest effect we can possibly conceive of.
So the idea that this grandeur is the result of chaotic, random quantum fluctuations, a completely unguided process, it just feels intuitively unsatisfying.
Random chance feels like an unacceptably small cause for the biggest possible effect.
Exactly. The simulation hypothesis offers a cause that feels proportionally correct. A godlike, post-human civilization with unimaginable power. It satisfies our need for the scale of the effect to be matched by the scale of the cause. It replaces the vast, cold emptiness of a random universe with a proportional, structured explanation.
And the final, most powerful driver, the reason it becomes such a compelling cultural narrative,
Is the illusion of control.
how so?
The simulation hypothesis, ironically, is comforting. Consider the two competing metaphysical realities. On one hand, you have a chaotic, meaningless, purely random universe governed only by indifferent physical laws.
A terrifying thought for many.
And on the other hand, you have a simulation that, even if its purpose isn't your own, still has a design structure, a programmer, and a framework.
So the hypothesis replaces the terror of a chaotic, random existence with the structure of a designed one. It means nothing is truly meaningless. It's all just running according to a set of rules.
It is the technological successor to our oldest creation myths. It simply swaps God for the developer and fate for the code. It gives us a framework, a context, and a comforting sense that the world we inhabit is knowable because it was, at some point, constructed.
It's a powerful cultural mirror, then, reflecting our desire for meaning and order.
I think so.
So let's summarize our findings on case file 042. We found that the core logical argument, the trilemma, is deeply vulnerable to the infinite regress objection, and it violates Occam's razor by requiring exponentially more complex assumptions.
Right. And the observable glitches in memory and perception are precisely explained by established neurology confabulation and the temporal lobe's dual processing theory.
Furthermore, the alleged fingerprints in the physics fine-tuning, pixelation, and code are mostly either selection biases explained by the Anthropic Principle, mathematical limits of our current theories, or powerful arguments from analogy.
The physical tests propose to falsify the hypothesis. They remain unperformable. Science and logic have largely resolved the case, confirming that this reality is, at the very least, internally consistent and operating under highly efficient mathematical rules.
We've closed most of the files, but we have to acknowledge one that remains stubbornly open and continues to challenge our psychological assumptions: the eerie fact of fine-tuning.
We offer the strongest logical rebuttal, the Anthropic Principle. We are the puddle marveling at the whole that allows us to exist. It's a necessary truth.
But here is the final prompt for you, the listener. The Anthropic Principle is a logical explanation, but is it a satisfying answer? We have confirmed that the evidence suggests reality is deeply structured, elegant, and efficient.
Certainty, however, is not a scientific measurement. It's a feeling. All the detailed evidence, the statistics, the physics, the psychology, it's all been laid out. The logical progression is now clear.
The final judgment on whether we are simulated is yours.
We've established that the simulation hypothesis is more robust as a philosophy and a psychological mirror than it is as a scientific theory. But let's close with one final provocative thought, building on that strange discovery by James Gates, Jr.
The finding that the complex mathematics underlying supersymmetry, the ultimate, most fundamental structures of the universe, utilizes the exact same supremely efficient error-correcting codes used in computer science.
It reveals an inherent deep efficiency and logical structure in the language of reality itself.
So if the underlying mathematical elegance of our reality is inherently structured, efficient, and capable of self-correction, what does that imply about the nature of base reality?
Does that mathematical inevitability suggest that the foundation of existence, the base reality, whatever it is also highly structured, perhaps designed? Or simply that mathematics itself is the ultimate inevitable constraint?
If the universe is written in an inherently efficient language, what implications does that have for our pursuit of knowledge? Does the structure of the cosmos mean that knowledge discovery isn't about finding external facts, but about recognizing the inevitable mathematical efficiencies that must exist in any coherent universe?
Something to mull over as you step back into your potentially programmed world. Thank you for joining us on this deep dive.